So welcome to the 39th session of day 5 of Wadla 3.0 on topics recent trends in deep learning and application. Today we have with us Mr. Amit Kumar from NVIDIA. So he is going to talk about the technical deep dive with code walkthrough into ways of addressing the limitations of large language model through NVIDIA, LLM, and generative AI full stack. So before starting his session, so I would like to introduce him first. So Amit Kumar works as a senior enterprise architect, generative AI, and deep learning at NVIDIA. He helps enterprise from various verticals build and architect end-to-end generative AI and LLM-based solution. He completed his BTech in 2010 from IIT Guwahati and pursuing higher education from Stanford University. He has previously worked at HP Research Lab, VMware, EFI, and got the opportunity to complete internships at Google as a summer of code students, Indian Statistical Institute, Kolkata, Technical University of Braunschweig, Germany. He has 7 patents in the area of deep learning, NLP, classical machine learning, statistical modeling, Industry 4.0, and 3D printing. His areas of enterprise include generative AI, LLM, NLP, computer vision, deep learning, statistical learning, ASR, TTS, GPUs, accelerated computing, AI for Industry 4.0, AI for healthcare, AI for robotics. So, welcome once again, Amit sir. And now the session is over to you.
Yep. Thank you so much, sir. And I'm really happy to be a part of this conference. And thank you so much for giving me the opportunity to talk and interact with you all. And please feel free to have any question. So the topic which I'm going to cover on this conference is on the LLMs, large language model. What are the challenges, as well as and how NVIDIA, and we all know, you might be knowing that NVIDIA is a leading, I would say that the leading provider of the ecosystem which sustains these LLMs, right? Not just at the GPU level, but also at the frameworks level, and at the libraries and whole this ecosystem NVIDIA provides. Right? So I'll just talk about it, that when we talk about LLMs, so what are the challenges are there, and obviously what are the so why this all everybody is talking about that, and how NVIDIA's frameworks, which are most of them are open source, are free to use, are able to solve that problem, and and how you would be able to use them efficiently. Okay. So if you have any question, please do ask, and yeah, and I just would like to I just share my screen. Yeah. Entire screen. Yeah. See, I think should be visible. Yeah. Yeah.
Yes, it is
Okay.
visible, sir.
Great. So I think you can just before I start, you can, and thank you so much, sir, for introduction, kind introduction, and you can connect me over LinkedIn, and this, if you type Amit Kumar NVIDIA, I think I have a decent page rank, so it should come. So I think you just you can connect me over it, and you can ask me any further doubts if you have. If you could not ask, let's say, I would prefer you ask me during this conference itself, unmute yourself and ask. And just in case if you have something else you want to ask, you can just any day ping me, giving the reference of this conference, right? And yeah, so I'll start my the topic which I mentioned, that how we can solve the problem of LLMs, and what NVIDIA especially. I mean, I'm not going to talk in general more that what LLM advantage. We all know that, and I'll briefly touch about that, and also I'll talk about how we can solve these problems, right? So. It's not necessary to reiterate that, but I would like to again briefly talk about it, what all the applications you think of coming out of this, large language models, especially when you talk about, and generative AI is a umbrella term under which LLMs being the one of the most prominent thing, right? And that's where you heard about this chat GPT based architecture, llama, all those kind of thing coming up and bringing the foundation model, right? And that gives you uh, it actually brings the foundation for building many application, correct? So the people who I would just use one analogy, that when iOS was being developed, right, when iOS came up, when Android came up, then you saw that how many apps development happened, right, on the top of it. The same thing is going to happen, and same thing is already happening here, right? The foundation model which you think of, whether it's GPT or large language model, DALL-E, right, the DALL-E, image to text, text to image, those kind of diffusion model. If those are the foundation model, then there will be thousands of downstream application apps that will be written upon those foundation model, right? And that's why it makes it generative AI and LLMs very unique. And apart from, and that's why you're hearing so much about this, because from one foundation model now you can derive thousands and thousands of applications. The way with one version of Android OS, now you can write thousands of application or even lakhs of application on the Play Store, right? So that's the potential of it. And so just three use case. One is the, I mean, multifold use case, but three categories I'm putting it. One is the something to do with the text generation. Another part is that art generation, right? You want to create images by putting the text. And third part is that, how we can use that to augment the imagery. That is the another use case. But now let me just I'll not talk, and other use cases, and some of the common use case, chatbot, we already know that. Translation, pretty common. Code, Copilot, right? You might be already knowing that now you can write your code using Copilot or Git Copilot, or many stuffs have come, right? But apart from that, there are many new areas as well where these things are being used. That is one example. I would say that drug discovery, right? So you give the structure of a give the sequence of mRNA, DNA, right, and or amino acid protein sequences, and it gives you the protein structure prediction, right, and how these two protein will interact. That's what people do in drug discovery. So those kind of thing are very much and models are available which people are doing it. So this is another, I would say, that pretty unique use case of large language models, right, for the drug discovery. Now, if you talk about, and it's just not limited to text. When we come about that, when we, and text application, you already know, question answering, smart searching, or you can rather than key word based searching, you can describe the what you want to achieve, and then it will give the response pretty much like the Chat GPT way, right? But even apart from that, when it comes to the visualization, that communication, then you have fashion designing, architecture, 3D animation, advertising, all those kind of things. There are many applications coming up, right? People are already using it. So how can I make this? Let's say for advertising industry, how they are consuming Gen AI, because now they can give the prompt, they can interact with the image using the text. Correct. So that's how these things are evolving or have already evolved. Now let me just come to before I talk about get into more technical details. Then just one thing I would like to make you aware on this thing, that why this large language model became so prominent. Correct. We had this BERT architecture, we had this transformer architecture, but when this autoregressive model came into, then why suddenly it became so much. I would say that every enterprise, every university is going after it. Why? What is the key reason? So I just would like to highlight the key reason is this much, that if you go via traditional approach, or I would not say traditional, I mean the language model, not so large language model, but and those kind of things, then you requires basically every time you do some train your fine tune your model for a downstream task, you need to fine tune the model, correct? But those are not in real sense the foundation model. If you say what is foundation model, Foundation model is okay. I have built one foundation model. Now for the new task, I don't have to every time fine tune it, because fine tuning a model, you need a data, and that fine tuning a model is a costly affair. You need a good amount of data. If your model is 175 billion parameter or 7 billion parameter, if you have just 100 data points, then it doesn't make sense. I mean, even if you fine tune it, nothing will happen. Model will not learn anything new from that data, right? So what is the advantage of this large language model is that it's zero shot response basically, right? Even basically you don't train anything, you try to get just the response as it is. That is zero shot response. Another thing is that if let's say if that is not working, the thing which made it one of the popularity is the prompt learning. You give some of the prompts to the model and then it starts learning. In that case, the model weights are not changing. It's not model is not fine tuning, but rather prompts. You're just doing the prompt learning. That you have just hundreds of prompts you give, then you can see the drift in the behavior of a model, and you see this that is a very powerful feature. If you think of a derived use case for every downstream task, for every you application, you don't have to train the model. You got the foundation model. Now you give some prompts and you can do it. But so that makes it very powerful, and then single model can serve all use cases, right? So that's why some people call it foundation model also. And but the one more thing happened, that okay, now you, instead of millions of parameter, like for example BERT used to be 324 million parameter, now you're talking in terms of billions of parameter, right? Llama 7b, Llama 13b, Mistral 7b, right? Llama 70b, GPT 3.5, 175b. B means billion, right? So model became big, but it became more general, right? Retraining need became less and less. So that is the basically main key aspect that we need to understand, that I want to emphasize, that why everywhere we are hearing about this, and why so many people are working on this. That is the key reason, I would say. Okay. Now, and see this how the demonstration I'm doing. Let's say if you ask any language models that what is the yellow part in the egg, and it will respond that this is the part that is suspended in the center of egg, right? You got some response, right? Now, same model, and how you can it will respond differently if you ask the same question, but you give it some context, right? If you give it some context, that is called the prompt learning, correct? If I am building a chatbot which is nutrition chatbot, then same language model, I'll ask the question in a different manner, right? I'll my question will be same, but I'll give some of the prompts, right? So the response will be related to nutrition. You see this, the yellow part in the egg is the yolk. It contains fat, cholesterol, and all those things. Prenatal chatbot, yellow part in the egg is rich in, it's telling you something which is good for prenatal, fetal development. Culinary, something which is related to food. So but for that you have not changed any foundation model, rather you have done the prompt learning, and that is very powerful feature, right? I just am giving you one example what I spoke in the previous day. I was talking about the why people are using foundation model. So this is the one of the examples just I gave, that just by a few responses, how you are shifting the domain of your chatbot, right? And this is just evolution. You see this how these things have evaluated, worked word to wake, fast text. I mean, that was 2016-17 time frame. And then if you see the evolution, we are talking about what cloud age, Jurassic, and a few days back uh, Maxwell also released something. Nvidia has Nemo based model. So I mean, you just think that it's the field of development is going I mean, uh, you see the acceleration, right? Acceleration is super fast. Essentially, all kind of architecture, Llama, Falcon. Just be aware of these architectures, and many you'll hear about it. Correct. Now, let me, and more or less these architecture are similar in a nature, right? They are autoregressive in a nature. What they are, if you ask me how Llama 2 is different from Mistral, not pretty much, on mainly in the data set it has seen, and also some of the computation techniques, right? That how it calculates the attention, but the fundamental architecture, the auto-regressive architecture, is pretty much same, right? So they belong to the auto-regressive architecture, so the a decoder only architecture part of transformer, right? Now, and so when we talk about that, let's say you want to build a foundation model, or somebody wants to build up any foundation model or work in LLM. So what are the challenges and building that foundation model? First of all, you need huge training data. And what training data is required? If I just may show you, training data is required around in trillions, right? So number of token used to train pre-train. When I say pre-train, it means that you are training models from scratch. What scratch means that your weights are random, right? Now, pre-training model from GPT-3 to Palm 2 or Llama, you see this from 600 billion, we are going to 1.4 trillion, 1.3 trillion token, right? So so now what is happening that the number of parameter which is required to train the model, data size is going up, is going more and more, it becoming in not just billion but the trillions. I'm talking about the token. Token means the sentences, not sentences, the word piece, the subset of a word which is fed into the model to train the model, right? So but the size of model is you see the typical range is 7 billion to 70 billion. That's all is the size going on, right? So mountains of training data, that's a challenge. Then you need a huge infrastructure and lots of GPUs, NVIDIA GPUs, right? And as well as CUDA, QDNN, all those kind of things are needed, and that's what OpenAI did. That's what every company who is building foundation model they are doing, right? Or even not just foundation model, even for model inferencing they are doing. The infrastructure requirement is relatively more, right? And also it requires technical expertise, because now when you are training large language model, you are not just training on a one laptop, right? You're training model on server which has multi-node, multi-GPU kind of setup, right? So those kind of thing has to be taken care of. And also how those, if you're training with a data set as a volume, it has 3 trillion token, then how those things will converge, that also requires some technical expertise. Challenges is that do you have any question? Okay, I heard somebody saying something, so I just paused. Yeah. Challenges is that though this LLMs, large language models, are pretty powerful, but they are, the one challenge is that they're frozen in time, right? If something it has not seen, it will make it up. Hallucination people call it, right? It will just try to, because it's supposed to generate the next text. That's what it does, and even if it does not have an answer, sometime, not sometime, many times, if you don't put the guardrail, it will keep on saying something. So that's a hallucination, provide undesired information. That is the one problem. Then frozen in time, correct? Let's say, for example, the world heard about COVID in what year, 2000, 2 3 years back. But let's say if I would have searched about if somebody would have built the foundation model in 2016 or 17 or 18. At that time, COVID was not so much. I mean, the word would have, you would not have found any word also, right? Your LLM will not understand the COVID if what does it mean, because it's not seen the data that is frozen in time, right? And also it does not contain any domain enterprise specific knowledge, because it has seen the general data, web crawl data, which is all over the net, right? So if you ask that, okay, these models, what is a very specific answer to this particular query, then obviously, since it has not seen the data, there it fails. So these are the challenges. So obviously it has many advantages, more advantage than challenges, but still these are the challenges that we should be aware of, and how to address that. We'll come to that, right? Now, I'll talk about that, you know, and let's talk about that, if like what all the data set that people are using. Let's say when Llama 2 was trained by Meta, right? GPT was trained by OpenAI. So, what kind of data set typically used? That's called multilingual web crawl data sets, source code, multi-domain, right? So these kind of data sets, yeah, so these are explicitly publicly available pre-training data sets. So a huge volume of data, people take it and they just use it, and they so that's why your one model is able to understand the English, is able to source code also, it understands, it can write the code also. It's a multi-domain, and you see the distribution of data which it has seen for model training. So, and these are the publicly available data. So, and this has been used for for training these foundation model. Now coming to that, how this, now let me go a bit more on the technical side of it. Now let's say uh, how this large language model, right? When we talk about a large language model, how they are trained or even inferencing. So let's say if the model is 70 billion, because llama 2 70 billion, right? How much it will be on the memory? It will be 140 GB. That will be your model size, right? If you're storing your model in FP16 format, 70 into 2, 140 GB, correct? That will be your model size. That model cannot fit into one GPU, right? Because one GPU, let's say 80 GB, it cannot fit into one GPU. Now, so what we can do? We need to split the model and put it across different GPU devices, right? Now, we cannot. So splitting data is easy, but splitting model is not easy, because you're cutting the model. I mean, managing that is not so easy. You can split the data. People who are familiar with deep learning and PyTorch and even TensorFlow, they might be knowing data parallel, right? Data distributed parallel, but in LLM, model parallelism is a necessity, is not an option, right? Because your model size is big. Now, to do that, how to achieve the model parallelism? So there are tensor and pipeline parallelism. There are two types. There's a sequence parallelism and there's a selective active recomputation. I will not go much in detail, but I just would like you to be aware of these things, because model parallelism go hand in hand with the LLMs, right? Because why? Because your model size is big. And why, if model size is big, what it means? It means that the model is consuming more memory, right? And what is the solution if model is consuming more memory? Solution is that we don't put model on one device, rather split the model and keep on different device, right? That's what is being done here. There are methods to do it, and since we are talking about GPU and all those kind of things, so NVIDIA provides efficient framework to do all of this GenAI stuff, LLM stuff, which I'm going to talk about it now. And but that anyway will contain all this tensor parallelism, pipeline parallelism, because if you want to do it, for us it's difficult task to do that, right? Some framework library should be enabling it, so that for a data scientist life becomes easy, right? Same thing becomes selective active recomputation. It is also another technique, optimization technique, where you want to save your memory of LLM, because LLMs are memory intensive, and you have to split the model and keep on the devices, right? Another concept I would like to talk about is the RLHF, that reinforcement learning, based on human feedback. Why? This is a very important step, in a sense that, because I mentioned this LLMs, right? This LLMs, that uh, they have a tendency to hallucinate, in a sense that they will keep on generating the text, and sometime you don't know that how it's gonna behave. But the one way to mitigate that problem is that you would like your answer, you would like your model response to align with human preference. Then what is the meaning of human preference? Okay, I would like my GPT or what llama answer to be helpful, and I would like it to be harmless, right? Let's say two things that I consider it to be important, right? So and you don't want it give to be toxic response, violent violence response, those kind of things you don't want to filter out. Then people do this model foundation model realignment, basically alignment with the human preference. That's a RLHF. And what they do is that and people have done it when they build the foundation model, all kind of foundation model. GPT, it was done. Llama, it was done. Mistral, it have been done, right? So what they do essentially is that whatever output is coming from the model, they rank it, right? And how much is how much it aligns with the human preference, right? And the more it aligns, the more model you are steering model towards more towards that. And if it's not aligning with human preference, like, I mean, if your model says that, okay, it talks, let's say, about violence or something, something which is not appropriate in society, right? You can, with reinforcement learning, RLHF, you can steer your model response towards, so that it aligns with human preferences. That's all it does, right? And it's a pretty much supervised process, in a sense that human annotators rank it, correct? So that's use of it essentially. And this is one of the way which people use to deal with the challenges of LLMs, correct? Because now you are aligning your preferences, models preferences, with the human preferences, because ultimately human will be the consumer of that model, correct? I think I'm just giving the example that there are the different techniques. You know, uh, uh, there are different techniques and why you should RLHF, and there and you see that when you combine RLHF with the and just supervised learning, then your response gets better and better, correct? And the more you do this RLHF reinforcement learning, and as and when your model sizes goes up, you see that the preferences are aligned more and more. Okay. Now let me another thing I would like to talk about, that RAG, you would have heard about it, retrieval augmented generation, right? And as I promised that the thing that the topic that I'll talking about is that the challenges of LLM and how to address, how NVIDIA frameworks address it. So RAG essentially is you have, as I mentioned, that these models are frozen in time, correct? Let's say I want to search any LLM or that what is temperature outside, correct? It cannot give me the real time response because it has not seen the real data, correct? So to respond in a real time, right? What LLM needs to talk to, what needs to talk to your database, right? And RAG actually is built upon top of it. So what we people do is that you put the query into the model, and rather than just searching that query into the model from the GenAI model, what RAG does is that it queries the documents, and it augments your query, right? So it's kind of to put it in simple English, it means that asking the right question to the model, right? You're asking some question to the model. If you have RAG enabled, then that your query will be uh, searched in the vector database, and then and since everything we are putting in the form of embedding, now for your generative LLM model, you are not just sending your query, but you are sending the chunks which are coming from the database, right? So what through this way, what is being done here is that you are asking the right question, and also to some extent you are able to deal with the problem which is coming because of hallucination, all those kind of things. So let's say if my the whatever fact I'm asking, let's say it's not available in LLM, right? But that information, if it's available in the knowledge base document, then I will be able to incorporate that information in my answer, correct? So that is the main purpose of RAG, and that's the utility of RAG, and that's how people that's how people are making use of this RAG model. Yeah, just hold on. Yeah. Any questions you have? Please ask me if you have any questions.
Thank you very much, Amit sir, for your wonderful talk. So, participants, if you have any questions, so feel free to ask. Madam, no questions. So, Amit sir, it seems no queries, no questions.
Sir,
Uh,
I had a small question.
yeah, you ask.
Is Sar present? Is Sar listening?
Hello, Amit sir, are you there? Oh, okay.
He might need to attend some phone call or something.
Oh, okay. Okay.
Okay. If you have any questions, please feel free to ask.
Hello, sir.
Yeah, please go ahead.
Like nowadays, many companies are trying to increase their context window from like 4K to 8K. Like you have to talking about these tokens, right?
Yeah.
Like What is the trade-off when we are trying to scale up this context window to some 16K, or like should we change some model architecture, or like what are the challenges when we are trying to do that?
Yeah, so it's basically context window is, yeah, essentially it depends on the model architecture, correct? So for example, when the llama came at that time, context window was less, correct? Now new models are coming up with the larger and larger context window, correct?
Yeah.
So that essentially for that model has to be, change essentially. It has to be at the architecture level, correct?
And also this data set should also be tuned like that, like it has that much context in it, something.
So that's how you basically, that's how you basically perform the training also, correct? So
Oh
one,
yeah.
two things, that what is the context length and what is the, the embedding size and how much token it has to produce, right? Max token size. So those things are determined one thing is that the main thing in the context window size, it determined your by the model architecture. And yeah, that's all. And that's how, once you have decided upon the model architecture, then that's how people fine tune their model, right? So for example, llama, from llama 1 to llama 2, the context window was doubled, right? It's, I think, 4000, and even as in your mistral, even it's more. So you see that this context window coming up more and more, right? So for that, as in when new architecture is coming, you'll see this context length, coming up more and more, increasing basically. Yeah.
Okay, and another question, these days, like LLMs are becoming popular, and also the techniques used, like the fine-tuning, pre-training, and
Yeah.
RLHF, and these RAG-based methods. These all methods are like coming known to all, and like even though all these methods are known to all, like why GPT-4 is only like at the top? Is there any secret sauce behind the GPT-4? If the all information known by all companies, then why can't they can clone the GPT-4 itself and bring it to the market?
So the GPT-4 architecture is, see, GPT 3.5 paper is open source, right? GPT-3, if you can search, GPT 3.5 paper is open source, but it's just not that, see, the architecture is pretty much known to everybody. What is that? No, no, a GPT-4 exact architecture is not known. I mean, you can make out that, okay, it's auto-regressive architecture because they have not made it open source, right? What is open source is Llama 2. GPT-4 is open source? No, it's not open source, correct?
Okay, it's
It's
okay.
not open source. It's a paid service, right? You GPT 3.5 is free, but GPT-4 you have to pay, right? They're it's a paid service, correct? So they're monetizing this thing. Meta came with Llama 2, which is actually open source, right? So now what enterprise is doing, the people who are actually working in these areas, and since I'm interacting with many of them, many people are, I mean, depends on, the folks, how they want to go ahead with, right? Some people want to, take the pre-trained model, open source model, and build upon it. Some people just want to, use the API and do their job. But that depends on the company to company also, right? If some company has, good amount of data scientists, they will take, obviously, find the pre-trained model and build upon it. But some company, they don't have that much data scientist, and the time to deliver project is pretty much less, then they just make a API call. But what happens that what happens that then you compromise on the flexibility part, correct? So the thing is, it has its own pros and cons. So now your question is that why everybody is not replicating the GPT-4 results. So no, I mean, it's not like that. The models, even open source models, I'm not saying they are beating, but they're reaching closer, right? If you see the Llama 270 billion, it's open source. Even source code you can get it. Even everything is available there. But its response is, in some of the areas, is pretty close to GPT-4, correct? But GPT-4 is your paid service. You think of that way, correct? And now, so if somebody has a some if you have an open source model, now that open source model, now you can, fine tune for your own use case, whatever you want to do with that model. You have everything, you have in under your control, correct? So that's the thing. And why GPT-4 is better, because lots of, is just not about the pipeline, but also about the other things. For example, SFT, supervised fine tuning, RLHF, how these things has been done, how good the data has been curated, right? And I'm saying that data is open to all data is using, but how people are filtering the data, how the data crunching piece is being done, that also matters, right? So that's how you see the differentiation, correct?
Yes, yes, sir, got it. And
Yeah.
also main thing like the data, how it is being curated and how it's trained is more important.
Exactly. How and the thing is that now the trend is like people are now once they have understood the power of this thing, now people want to build their chatbot for their own use. For example, I'll give you the thing what NVIDIA did with the one company, Bloomberg. You know that Bloomberg company. Bloomberg, you would have heard the news, right? So Bloomberg company, they made the GPT. It's called Bloomberg GPT, correct? If you search the Google, you will get it. Uh,
Yes, sir, I
uh,
heard about that Bloomberg. It has
yeah,
many like big parameters like
exactly, and then Bloomberg GPT actually beats GPT architecture. It beats. You asked this question, right? And this actually beats GPT architecture because this is a, but where it beats, not everywhere. The paper has been written, and NVIDIA and they both actually built this one. So it beats in financial data set, right? Not in general data set, right? So because it's a purpose built model, you understand this one? Large language model for finance. You get it? Yeah.
yeah, sir.
So
For
so
specific task.
yeah, so essentially, so now the trend is that people are building domain-specific models, correct? One is okay, general model, you it can give answer, it's like jack of all trade, master of none, right? Those kind of model. But another trend is that okay, I want to build a domain-specific model which does very, very good job at let's say finance domain, health domain, right? So that's what the trend is. That's what many people are preferring, and that's what yeah.
Yes, sir, got it. Thank you.
Okay, so now coming to the addressing the challenges, right, of this thing. So what we can do is that what another thing is that guardrail, right? And just you must maybe aware of this term guardrail, is that whatever response I mentioned that the negativity of the downside of LLMs, which whatever is downside, you basically address it through RLHF is one way, RAG is another way. Uh, uh, SFT, supervised fine tuning, another way. But there's another a very commonly used is the guardrails. Basically, whatever response that you are getting before you give it to the user, right? You just pass it through, some filter. Basically, filter. If it's unethical, don't give the response. If it's toxic, don't give the response. If it's biased, don't give the response. If it's harmful, don't give the response, right? And if it passes that safety filter check, then do the response. And if it's gives some bad response, then it says that this is unethical question, I'm sorry but I cannot respond to your question, right? So those kind of things have been done and you try it out, and many of the chatbot have actually has incorporated this one, right? Now what NVIDIA has to offer, see, NVIDIA offers on generative AI the three things, I would say. On the language, whatever NVIDIA does is called NEMO, NEMO, NEMO. BioNeMo is what NVIDIA does when it comes to drug discovery, protein structure prediction. Ultimately, it's at the heart of its language model only, correct? The transformer architecture, but BioNeMo framework and whatever it has to do in the VLMs, right? Vision language model, whether it's a text to image, right? And text to 3D, text to video, all those things comes under Picasso. Right? So these are the software stack, basically application framework, not just GPUs. And GPU anyway, I mean, you have this on-premise GPU on the cloud, those things, but they are just a GPU. But these are the what I'm talking about is the software, the application framework, so that people are using this framework to build their model, to fine tune their model, to deploy their model, right? So that's how this Nemo for LM, that's how it looks like. And you ask me that, okay, why should I use this? It's open source anyway. What you can do is that, you if you want to achieve training time, lesser training time. For example, somebody's training or fine tuning the model. I was mentioning that distributed training, right? Distributed training and model parallelism is something which a framework should provide. That's what Nemo provides. That's one of the things that Nemo provides, so that you can train your model efficiently. Not just model training, you can whatever data curation is required, because there are lots of, if you're doing web crawling, there are lots of deduplication has to be done, because you so all those kind of data curation, file formatting and putting into appropriate format so that model can understand are done in data curation steps. So all those function libraries, which are functions basically, which are accelerated, which are parallelized, are provided into this framework. then you can customize your model, and which you are asking something, right? The p tuning, parameter efficient tuning, low rank adaptation, LoRa, and IA3, all those kind of things, model customization things are available, right? And then also inferencing, how I can so if once I have trained the model, and if I have to deploy it, how can I, because these models are pretty big in size, how can I deploy it so that I can get the response as quick as possible? If you simply deploy, Llama others model without any optimization, the latency will be pretty bad. Yeah. So that's what it Nemo provides. So you see this end to end. You see this from model training, data curation, from distributed training to accelerated inferencing, guardrails, everything it provides. And what are the models it supports, and are or I mean just being supported: Falcon, Llama, right, Starcoder, GPT, Inform. So all those architectures are supported, and this is just ongoing list. You see this, we have put it into different bucket: community built model, balance of accuracy and latency, complex tasks, right? Just those kind of models are available within Nemo, which you can try it out on, from where you from NVIDIA website, or you can get it from Hugging Face, wherever you want some of the model. So I was talking about this one. See, what all things are required for model customization are available in this one, and generally those things are typically done. Is few shot learning, prompt engineering, then prompt learning, then parameter efficient fine tuning, adapters, LoRa, IA3, right? Then it's instruction tuning, right? Instruction tuning. There's SFT, supervised fine tuning, and RLHF. So what it means that when framework support, it means that these things you can do with the Nemo framework without much coding, basically, right? It provides you the framework essentially. You don't have to write the logic for SFT or RLHF or adapters. I mean, it provides you the functionality, and so that you can, use it so that your coding becomes very, very easy. Now, before I go to, before I, and if you want to search Nemo, since it's open, one piece of it's open source, I would like just search NEMO, and you'll find it. For this, you'll find both. Um, Link, the first link which comes, you'll find it. This one, GitHub. If you want to look at GitHub, just look at GitHub, or you can uh, put it here. And Nemo is available as a cloud API, the way ChatGPT is, or it's available as a open source also, so that you can, it's message as part. Yeah, let me put the message. Or you can actually use this as a cloud API, or you can use this as a on-prem. Right? You don't want to send your data to the cloud. You want inferencing to happening on-premise, right? Then I will you will say that, okay, I don't need API. I will use that as a on-premise, right? So that's also it provides you. So inside Nemo, if you go examples, or let me where is or vision NLP, right? Language modeling, you see this. I mean, all kind of things that you will see here. Tuning, what I was talking about, correct? Megatron, GPT-5, all those, even source codes are available. Pretty much results as GPT, T5 adapters, everything is available, source code and whatever you need. Right? Now, to do programming with this one, or get the result. Now, second thing I would like to, since we don't have much time, I'll quickly cover on the performance part. That see, once you have, let's say, trained the model, correct? Once you have trained the model, now we have to optimize this model for inferencing, correct? So let me take the and if you optimize this model just by using, if you don't use the right set of library, right? And if you just use the GPUs, then you'll not get that much performance. For example, let's say I am Llama 2. I'm doing inferencing, well, inference prediction basically I'm doing. If I use A100 Ampere series GPU, and if I use H100, that is Hopper series GPU, Hopper series GPU is 2.6 times faster than Ampere series GPU. See this Llama 2, the first, I cannot highlight, but yeah, I can highlight. Yeah, you see this one. Okay. Let me just highlight something. Okay, I'm sorry. Yeah. This portion, can you see this? Yeah, so 2.6, you have, 2.6 is times faster, but it is just H100. But the moment you do H100 with TRTLM library, this is a library, acceleration library, right? then you get the more performance on the same speed. The question is that, okay, then why should I bother about this? Because this inference, if the response that you are getting from large language model is pretty slow, I mean getting not real time response, then beyond a point it does not become very very useful, correct? So that's why this thing is becomes very important. And also second thing is that not just it should be fast, but also it should be the throughput also should be faster. What do you mean by throughput should be faster? Faster essentially, so that if a server if somebody is requesting, if somebody is putting so many requests within a certain time period, then those many requests has to be served. That is called throughput, right? Within certain set of within certain threshold of a latency. So this library basically TensorRT LLM enables you to do that. Understand? This actually enables you to do that. So I'm just showing you the benchmark number. What you know. So H100 GPU, it achieves 4.6 times faster than A100 on TensorRT LLM. Right? You see this acceleration, right? So that's why you see a lot of scarcity in the market was for Hopper series because of this. Because Gen AI for LLM application, this is the go-to GPU, that is H100, because of this performance, right? And same performance goes for model training, same performance goes for model inferencing, and so that, and same thing goes for model throughput essentially, so that with one GPU in the system you can serve more and more requests per second. Now, how it achieves that, I would not go much in detail, but I would just like to, internally what NVIDIA is doing here, writing the software. So what NVIDIA has done in TensorRT LM is that we use something called in-flight batching, right? What it basically maximizes GPU utilization during the LLM serving, right? So whenever somebody is, sending you the stream of tokens, so that asking the question or search engine, whatever, the chat GPT, the way you ask. Now, how the static batching will work versus how the in-flight batching works, you can see this, right? So this software, essentially the TensorRT library, essentially internally takes care of this thing, so that you get the fast response. Second thing is that optimize attention, the way attention mechanism is calculated, right? Whether it's a multi-query, grouped query, multi-head, right? So what it does is that we support the computation part for MHA, that is multi-head, MQA, multi-query, GQA, group query attention, right? And also the CUDA kernels has been written for encoder, decoder, as well as context and prefill. So all of these things actually results into the optimization. Similarly called KV cache optimization. This is also used in TensorRT, Triton Inference Server, so that you get those kind of performance which I was talking about. Why all this are needed? Because LLMs are memory intensive, correct? And when you are doing the inferencing, when you are producing the tokens, then the cache memory requirement goes up. So how to minimize that? So this actually techniques enables to do that efficiently. And that's pretty much I wanted to cover. And let me just yeah, just to make it more relatable, yeah, that's pretty much I want to cover. And these things run on the cloud. These things run on your infrastructure, on your cloud, on premise, everywhere it can run, right? And this is more on the other architecture which NVIDIA has come up with, and we have actually NVIDIA has come up with the Grace Hopper now, not just GPU but the CPU also, right? So you have a Grace Hopper 200, we call it. So this is the not in the market yet, but this another, you have a Grace CPU and GPU linked together with NVLink, and that gives you enormous memory. And so why it's needed? Because of this, because I was mentioning again and again that this LLMs recommendation engine, all those are memory intensive application. To enable it, you need a memory, those kind of chips which I was talking about, Grace Hopper. So Grace is based upon ARM architecture on the SIP, right? So on the CPU side. And use cases, yeah, LLM, recommender system, graphical neural network, vector database, drug discovery, all those kind of use cases are being done. Any questions you have before I stop? So please feel free to ask me any question. And if you don't want to ask me now, you can actually ask me on LinkedIn. Yeah. So and you can just give me the what that's called reference of reference of Wadla conference, and I'll be more than happy to respond to you. Thank you so much. Yeah.
your wonderful talk. So, as you have introduced, you highlighted the important recent trends on like LLM or other models. So that was really amazing. So once again, thank you very much. And yeah, there are some couple of questions from the participants. So they would
Yeah.
like to ask.
Yeah, please go ahead. Yeah, that's why I just left 5 minutes time so that we can have this question asking. Yeah, please go ahead. Somebody's typing it, or should I?
He is just saying, yeah.
Yeah,
Good afternoon, sir.
yeah.
Sir, the current trend goes into the generative AI and all the most marketing and advertising. It's about generative AI. So, where do you think predictive AI stands against this all? Because there are very few news about predictive AI in general.
Look, predictive AI, see, generative AI is obviously is in boom, right? Because of the application. But it doesn't mean that predictive AI has gone somewhere. It's just that matter of time, right? At this point of time, there are many use cases which are coming in generative AI. But predictive AI is like the traditional industrial scenario, right? It's still being used. Correct. If you want to do, let's say, predictive maintenance or time series analysis, forecasting, there generative AI. I mean, you can't do any. You can use transformer, but you are using transformer just as a replacement of RNN, but you're not actually using the decoder type generative AI per se, right? Generating response. So it has its own place. It's being used, but I would say that yeah, generative AI is that being since it's new, and also it has enormous potential, and also it the use case wise it's versatile, right? Because you can think of search engine, recommendation system, whatever, chatbot, even if you have to write something caption for photo on Facebook, you can use chat GPT for that, correct? Or even Alama for that, correct? So it connects with the many use cases, but it's just that yeah, but it doesn't mean anyway that predictive maintenance or the traditional that's not even traditional. I mean, I would say that the other class which you mentioned is less important. No, it's still pretty much there. Yeah.
And so another quick question is, like in predictive AI, where we have some definite evaluation measures, but in generative AI, most of the measures depend on feedback from human systems. So, how short can we, or how long can we expect some definite evaluation measures in the generative AI systems?
Sorry, I lost you. Just can you repeat your question, please? Yeah.
Most of the evaluation measures for this generative AI are based on human feedbacks, right?
Yeah, yeah.
So, how, like, in how much time can we expect some definite evaluation measures which are like computerized for the
See,
generative?
it's not like that computerized feedbacks are not available. They are available. And if you see the matrix, right, there are many matrix which are some of the name I can blue. I mean, the matrix which has been done, and even people are using one LLM res to assess the response of another LLM. Those kind of things are being done, right? But you ask me why human response? I don't think it's not going to go anytime soon, because as long as, because those you want to have it validated by human, right? Because human will be the user of that model for this particular reason, right? But I think, see, if you see any matrix, it's combination of human response, what is how humans are ranking the model, and also not ranking, evaluating the response, and also in you have typical score, which is things are lots of innovation is coming in that area as well. But in my view, or it's not human response, human response will be always be there, because at least for some time being, or there's no need, actually, reason being, because the foundation model is one time job, right? You need to evaluate the foundation model. If you're happy with the foundation model, it's done then, right? And because human are the consumer of this model, so they would like, they deliberately want to have a human evaluator. You ask me that human annotator, yeah, that's a different question. You want to reduce the effort from human annotation, then active learning and all those things are used, that's different thing, that even desirable, people do it, but that's more of a supervised learning kind of thing, correct? But annotation, evaluation, we deliberately want it. Yeah.
Thank you, sir. Thank you for your wonderful answers. Have a good day.
Yeah, my pleasure. Any other question, you can LinkedIn, you can type me. Thank you so much. Yeah. My pleasure. Thank you so much for giving opportunity. Yeah.